Ever tried coding a game and it turned into a complete mess? So there's a better way. Instead of chaos, what if we had a blueprint that made everything reusable and organized? That's where object oriented programming comes in. Think of it as a game engine for your code, which is efficient, scalable, and clean. So let me break it down for you, and we'll make our own mini game framework using Oops, and we'll learn more about it in the video. So if that sounds interesting to you, let's dive in. What is object oriented programming, right? It's a programming style that focuses on creating objects that can interact with one another. So there are four concepts in OOPS: class, object, attribute, method. Class is a blueprint that is used to create objects. Object, it's an instance or a sample of a class with specific values. Attribute, it's basically the object's property. And method, these are functions inside a class that defines object behavior. Basically, what an object does is defined by this method, which is being written inside a class. So here's an example of creating a class and object. We have created a class car. This is the syntax, then a colon. Then we'll define the constructor here. This is the constructor. So in order to define a constructor, where we'll write the attribute of it, we'll use underscore underscore init underscore underscore. Then we'll write the shelf parameter. Then we'll write the attributes name. Again, semicolon, and inside that we'll use the self parameter to assign the values of the parameters, assign the values of the attributes or the object properties. Now we'll create a function method inside the class, similar to how we make a function, and then we'll write inside one statement car. We can use those attributes inside the functions as well in that class. So we have created the class here. Now we'll create object, and in Python it's pretty simple. We'll write the variable name, then we'll use the class, and then we'll assign the attribute values. Basically, brand name Toyota and the model name is Camry, Honda Civic. So now we'll call out the object function. So in order to call out it, we'll write the object name, then dot, then the function or method name, and then close with the parenthesis. Now let's run this. Yeah. Okay. Now coming to the classes and objects in Python, as I've already told you, is a blueprint. It's an instance, and objects are attributes and behavior. So another example of classes and objects, similar to the one we have built it before. Basically, there's a class player, there's a constructor which defines the attribute name, attribute level. Then it has a function name introduce which uses those attributes and print a statement like name is at level dash. Uh, Remember this example, we'll be using this to create a game in our game in our program. Okay, so let's run this. Night is at level 5. Okay, good. Now here's a mini challenge. Let's do that. So in order to do that, I'll just copy this example to make it fast. Then just change the class name to book. Then I'll change this to title, and then this change to author. Okay, title, author, title, author. Usually we keep the attribute name same as the parameter name that we have assigned. It's pretty easier to do that way. Title, and the book is written by author. And now we'll do that. Book 1, introduce, and we'll write instead of title, the monk who sold his Ferrari by Robin Sharma. Now let's do that. The book, the monk who sold his Ferrari. This is written by Robin Sharma. That's it. Now coming to the 4 pillars of OOPS. Basically, OOPS has 4 main properties that we need to learn. First is encapsulation, basically wrapping up of the data and its data members into a single unit. Basically, we are data hiding and data protecting. Imagine a bank account where users can directly change the balance. If we can, we can obviously increase our balance any day, right? So, in order to make it unaccessible to anyone, in order to make it private, in order to make it something which cannot be changed directly by the user, but to perform something and then you can change, this is a property that comes into play. Okay, so bank class, then we'll define the attribute balance, then we'll define a deposit function, then we'll define a withdraw function, and then we'll define a get balance function. So now we have created a bank account where the balance is 1000. Now we deposit 500 and then we get the balance 1500, right? But we cannot change the balance by itself. We have to deposit using the deposit function. So that is a private attribute. And how do we create a private attribute? By giving underscores before the attribute name. Now coming to abstractions, basically we are hiding implementation details. So here we hide the implementation details. Basically we hide the essential part and show the feature part to the users. Think of smartphone, you press the button and it just works. We don't care about how it works behind. Okay, that kind of implementation is done by abstraction. And in order to implement this into our code, into this code, we have to import it from the ABC. Okay, ABC class. These are the abstract base class. And will you also import the abstract method? It's a decorator which makes the method abstract and should be implemented by the subclasses. Okay, otherwise the subclasses won't get initiated. So when we make a class called animal, we init the ABC class, then we make this function an abstract and we write pass inside it, because an abstract method does not require anything inside it, any block of code inside it. It should be abstract. It acts as a template for the subclasses. Okay, so make the class dog, inherit the class animal, and then we make the sound. We'll define the same function. As I said, we have to initiate it. Then we write print woof. Similarly for cat, print meow, and then we run this, we get woof. Okay, what if we write just pass inside it? See, can initiate abstract class dog with abstract method make sound. So we need to initiate those method. Okay, so let's make it. Now, why use abstraction? As I have already said, all subclasses must implement the abstract method, okay, otherwise it won't get initiated. Acts as a template for future subclasses, helps in reusability and maintainability. Okay, inheritance, reusing code. Okay, why write the same code twice? Inherits it. Exactly. Here we inherit the classes animal, so we do not have to write another time. We can just inherit it. So we have created a class where we have created a attribute called name, then we have created a function called speak, has a print statement inside it. Now we created another class called dog, will inherit animal, okay, then we'll create the function speak, then we can use those attributes which are defined inside the parent class inside the child class. Okay, so we do not have to write again, uh, again create a constructor and make a name attribute. We can just use it from the animal, so we can create number of attributes and we can just use it inside our objects. This is helpful in making a game where a player has certain attributes which are common to every characters in that game. We can just make it a attribute, and while creating those characters as an objects, we can import all those attributes all at once. We do not have to write again and again. I'll show you at the end of this video, so stay tuned. Now let's run this. Buddy says woof. Okay, now polymorphism, same interface, different behavior. Basically we are creating same function but it behaves differently for different classes. So we have created a parent class bird, we have defined the function fly. Now it has written some birds can fly, but in class sparrow we inherit the bird and then we override the function fly and we write sparrow flies high. And when we make the class function penguin, we write prints penguin cannot fly. Now see, when I run this, see, for bird in sparrow, sparrows fly high. For birds in penguin, penguins cannot fly. Bird dot fly. In both of them, fly function is being called, but acts are differently for different classes. That's called polymorphism. One function act differently in different situation. Okay. Now coming to method overloading and method overriding. So Python doesn't support method overloading in traditional sense like Java and C++ do, but we can achieve it through default arguments. I'll show you in an example. Also, method overriding is fully supported in Python OOPS principle. Let's see an example of method overloading. Here we create class called method of math operation, then we create a function called add, then we write a self parameter, then all this parameters such as a, b and c. Okay, even if we do not write 0 here, it will automatically assign 0. Okay, so like a has assigned 0. Now we create an object math operation for the class math operation. Now we called upon the add function. Okay, let's first run this and I'll tell you more about it. So math object dot add 5. So it will just only add this 5 which is stored in a. Now we have added 5 and 10. So a plus b gives 15. 5, 10, 20, 35. So 1 argument, 2 argument, 3 argument. This approach simulates method overloading in Python without needing multiple function definitions. We do not have to create multiple function definition, such as for 1 argument we have to create another, 2 argument another, 3 argument another. Basically we can just simply do it. How many arguments we are giving it, it will take it, it will return the operation. Now, example of function overriding. Function overriding means what? We are overriding the function like we have done it here. We are override the function fly. So it says differently in different classes, right? Similarly, we are inheriting parent class and we have override the functions show. So now let's see, it won't show parent method, it shows child method in the output. Now, as I've said you before, we'll be creating our own oops based game framework. Okay, so let's make that. Let's take something and let's copy a program here in order to make it easy. Okay, let's start. Character. Okay, so character has a name, right? Okay, we are giving it another attribute called health. Then we'll give it another attribute called attack power. Okay, now we have to create those attributes. Okay, another for attack power. Okay, so we have created those attributes for the character, which are name, health, and attack, means how much attack it can do. Let's create a function for it. Okay, so let me write it from scratch. Attack. Okay, attack function for the character self enemy, where we'll take the enemy and will attack it using the attack function, and it will decrease the enemy's health. So we have to minus the enemy's health, right? Enemy dot health. Okay, minus is equals to self dot attack power, right? So what I have done here is I've created an enemy and it has health, right? Now whenever I use the attack function, it will take my attack power and subtract it from the health of the enemy. Okay, now coming to the print statement, let's print it. Okay, self dot name attacks enemy dot name and reduces health to enemy dot health. Okay, so now we just need to create our heroes. Now we have created the class called character. Now this class can be used again and again to create characters. Like firstly we'll create a character hero, right? So we'll use our character class, we'll give it a name, knight. Okay, it has health 100 and it has attack power 20. Okay, now we'll create enemy using this same, right? Is equals to character. Now we'll make a enemy called dragon. Feels good. Dragon. Then let's give it health around 100 obviously, and it has attack power 30. It should have attack power more than the hero because it's a powerful villain. Now let's first let's attack the enemy. So hero uses his attack function to attack the enemy. So right, now let's run this. See, basically, Knight attacks dragon and reduces health to 80. Reduces its health to 80. So here it works. Now let's make the enemy attack the hero. And yeah, dragon attacks knight and reduces its health to 70. So this is the basic principle, basic framework that can be used inside an RPG model game to simulate those scores, simulate those health points, attack points. That's where oops comes in. And now you know. Okay. So all in all, in summary, we know that oops makes classes and objects, encapsulation hides the data, abstraction simplifies complex logic, inheritance promotes reusability of the code, and polymorphism allows flexibility in methods usage. Coming to module 8, we'll be tackling error handling and debugging. Okay, so stay tuned for that video. Now you know how to create a oops based game framework, and now you know why it is used, why it matters. So I have a question for you. What real world problem would you solve using oops? Drop your ideas in the comments below. Do like and share and subscribe the channel. Catch you out in the next video. Peace.